In the previous lecture, you learned about the hardware components of this course, and now I'm going to talk about the software side of the project and of the course. There is a GitHub repository where I have uploaded all the relevant software code, as well as schematics and KiCad projects. You can see the root of the repository here. I have broken down the content here into folders so that hopefully you can navigate easily through it. So let's have a look through it. You can see that in the first folder, I've got code and schematics that relate to the BME 280 lectures. So here's an example of a schematic. This is a PNG file with a schematic that I show in the course. You can download it from here. We can just view it. There is Python code, exactly as I demonstrated in the lecture, so you can copy it from here instead of having to type it in. There's a text file here with the prerequisites to get a particular example to work. In this case, to get the BME 280 example to work, shows you what to install first, how to install it, examples of source code. Basically, this is the commands that you see me typing in the particular lecture here. You can simply copy from here instead of having to type it in, hopefully avoiding any typos, especially for more involved commands and URLs and things like that, where typos are very likely to happen. So I repeat the same kind of structure with other sections of lectures. This one, for example, has to do with the code and content relevant to the HC12 transceiver, and I've got code and schematics for both the ESP32 and the Raspberry Pi in here. So you find that for the BME 280, the HC12 and the OLED lectures. Then I have a place for you to copy the original RPI full stack application. I recommend that you get these files from your existing installation of the Raspberry Pi full stack if you have it available, but if you don't, you can just fall back and copy the code that I've got here. This comes from my own installation, including, you can see there's a database file here that contains about 10,000 rows. My original database file at the time I'm recording this contains about 400,000 or 500,000 rows in the SQLite 3 database, but I pruned that to about 10,000 just to keep the size down. But you can copy that and then you can work your way through modifying this installation version. Then you've got the restored and fixed Raspberry Pi full stack application. Again, this comes from the course itself. So as I am working my way to restore the original Raspberry Pi full stack application so that it works with the new hardware, then I captured that result of that work and I committed it into the GitHub repository. So I have uploaded it here and you can use it to compare your work against the work that you see on the course itself. Most likely you are not going to need to draw from this code here. It's just for your reference, since you'll be working to restore your own Raspberry Pi full stack application, or at least the original version of mine from this repository. But if you need to reference to the code that you see on the course and on the various lectures, you can do so here. Just one thing that I want to point out at this point is that you can see this JSON file here. This is my API authentication and authorization file from the Google API. And obviously this is not going to be useful to you because I've replaced all the identifying information now with just placeholders. But anything to do with API keys and authentication files, you will need to get your own from places like the Google API, Plotly, or if this and that. But I did leave the placeholders here so that you know where things go. All right, so one step back. Here is the final project once it's fully upgraded for the new hardware with the new functionality enabled. So again, you probably will not need to copy anything out of this code, but it is here for your reference, because my advice for you is to just work on upgrading your own code base based on the information and the instruction that you see in the course instead of just copying the final result. So the final result is here. I've uploaded it and provided it to you to use as reference. Now, the other thing to remember here is that from time to time, I'm going to be making improvements and changes, so you will be able to find them here as well. So it is likely that by the time that you access this GitHub repository, it will look slightly different to what you see here. So there may be a new directory here, for example, with new code, or the code in here may have progressed to newer versions because it is a live project, and I will be making changes to it as time goes. So just be aware that things may change. You can see the commits here. You can see any changes, and you can see the before a change and the after change state of the code as well. If you're familiar with how Git and GitHub works, just remember commits is a term that describes the changes to the repository over time. So you can see what's changed and what's the same here. Okay, so that's about it with the GitHub repository for the course. In the next lecture, I'm going to give you a demonstration of what the final application will look like so that you know what we're targeting for.